Audible?
Good morning, sir.
Yes, very good morning.
Good morning, sir.
Good morning. Yesterday we have discussed general introduction of symmetry and certain rules to understand the molecular point group, or sorry, symmetrical elements, especially axis of rotation. So that is we have completed. So there are main 4 symmetry element, out of which 2 we have understand little bit yesterday. That is, one is identity, and second one is, you can say, uh, axis of rotation. Okay, so in today's lecture we are going to in continuation with that rotation axis. So see, you know very well, rotation axis is nothing but imaginary line about which you can give the rotation to molecule, then you will get equivalent structure. So that is we call rotation axis. For example, in the case of BF3, which one is a rotation axis? When passing through which atom? This is a BF3. If you want F1 in the position of F3, then what will be the axis?
C3.
C3, yes. And it is passing through
Boron.
boron. So this is your C3. Passing through boron atom. So this is principal axis. Sorry, this is one of the axis, you can say. Now see, apart from this, if you give rotation about this C3, so 3 atoms can change their position. But see, apart from this, you can have this axis which is in the plane of board or in the plane of mobile. This axis is, you can say, C2. If you give rotation at 180, then F2 and F3 can change their position. If you apply this C2, then it is passing through F1. So F1 remains as it is. Remaining 2 atoms, that is, you can say F2 and F3 can change their position. F3 coming to position of F2 and F2 coming to position of F3. Here it is F2 and here it is F3. So this is called C2. So how many such C2 are there in this molecule? One of the example I have given, where F1 remains as it is and F2 and F3 can change their position. So how many other C2? Yes. Passing through?
F3 and F2.
Yes, F3. One is passing through F3 and second one is through
F2.
F2. Good. This is another C2. If you apply this C2, then you can have this result. See, F3 remains as it is. F1 and F2 can change their position. And this is third one, see. Okay, at 180, these three can change their position. Here, F1 and F3 can change their position. So there are 3 such F2. See, in this platinum Cl4, which one is C2 axis? Sorry, or which one is highest fold axis? What is called axis which is passing through platinum?
C4.
C4, good. इसमें जो platinum में से C pass होगी, that is C4. Apart from this C4, how many other C2 are there?
2C2.
There are 4 C2. See, one C2 is passing through Cl1 and Cl3. This one.
Yes, sir. And C2, C4.
C4, of course, is there. It is passing through platinum. Cl1 come to Cl4, Cl4 coming to position of Cl3. This is there. But apart from this C4, C4 is on our side. It is perpendicular to plane of mobile. So apart from this C4, we are checking other axes. So among them, one of them is C2, that is passing through Cl1, platinum and Cl3. If you apply this
Yes.
axis, then what happens? This 3 atom remains as it is. At 180, at angle of 180, Cl4 and Cl2 can change their position. These two atoms can change their position. How many such C2 are there?
Cl2 and Cl4.
One is passing through Cl4 and Cl2. Good. This is second C2. What's about third one? Of course, if you take this C2, then 1 and 3 can change their position. Cl1 and 3 can change their position. Now, see, this is another C2 passing through platinum. If you give rotation at 180, this is also in the plane of your mobile. If you give rotation at 180, what happens? Cl1 goes to position of
Cl4.
Cl4 and 1 can change their position. Similar way, Cl3 and 2 can change their position. What's about another C2? These are the three C2. Is there any other C2? Here it is, this one, where Cl1 and 2 can change their position. So how many C2 are there?
4 C2.
Four C2 are there. One C4 is there. Here one C3 is there. And three C2 are there. Of course, three C2 are perpendicular to C3. Because C3 is on our side and C3 is in the plane of mobile. Here also same thing is there. What's about in benzene? What is called axis which is passing through center? What do you call this axis? Passing through its center. C?
Principal C2.
This is C6. Because 360 circle is divided into 6 parts. If you want to 1 in the position of 2, then angle of rotation required is 60. And therefore it's a 360 divided by 60, that is nothing but, you can say, 6. So therefore n is equal to 6, C6. Now apart from this C6, how many C2 are there? C6 is the highest pole axis and C2 is the lowest pole. C2 is called two-fold axis, C6 is called six-fold axis, C3 is called three-fold axis, C4 is there, it is called four-fold axis. So see, highest pole is here C6. If fold is highest, n is highest, then angle is lowest. If angle is increases, then fold is decreases. Okay, these two are inversely proportional. Now you tell me how many C2 are there? This is one
Six.
C2. Yes.
Six.
This is one C2, yes, passing through 1 and 4. Second C2 passing through 2 and 5. Third C2 passing through 3 and 6. Remaining 3 C2 are in between bond. That is, one is passing through between 1 and 6 and 3 and 4. This one, second one, and this is third one. So there are 6 C2 and 1 C6. So see, among these two, highest pole is this one. This is highest pole. And all they are, see, proper rotation axis. All these are proper rotation axis. Proper rotation axis, that is called Cn, is again two type. In the proper rotation axis, you can have a principal axis and subsidiary axis. Principal axis, that is main axis, principal axis, and subsidiary axis. So see, principal axis is nothing but how to define it. So it is passing through maximum number of atom and highest pole axis. So principal axis is a highest pole axis which passing through maximum number of atom. That is we call principal axis. Condition here is when molecule have more than one rotation axis or in a different order or in a different fold, Then the highest pole axis, this is very important. Highest pole axis passing through maximum number of atom. एक से ज्यादा अगर highest pole axis है तो आपको ये चीज देखना है कि it is passing through maximum number of atom. अगर एक से ज्यादा है तो एक ही है highest pole तो कोई दिक्कत नहीं है. Okay, so this is we call principal axis. Now you tell me which axis is there as a principal axis in benzene.
C2.
C2 का fold कितना है इसका?
C6.
C6. See, C2 is a two-fold axis and C6 is a six-fold. So C6 is a highest-pole axis. It is principal axis. And remaining all other axis, highest number नहीं पूछ रहा हूँ मैं. 6 C2 है वो नहीं. कितनी C2 है ये चीज नहीं पूछ रहा हूँ. कितने fold की C2 है? एक C2 means दो fold. C6 means six-fold axis. Okay, so highest pole axis passing through maximum number of atom, which is called principal axis, that is C6, and remaining all axes are subsidiary axis. So C2 is subsidiary axis. You tell me which one is a principal axis in BF3? Which one is highest pole?
C3.
C3, good. This is a principal axis, highest pole axis. What's about in platinum Cl4?
C4.
C4, yes. Remaining axis, that is C2, are called subsidiary axis. So see, this is the definition of principal axis. Principal axis, which is passing through maximum number of atom, or you can say highest pole axis passing through maximum number of atom. So that is we call principal axis, and remaining all axes are called subsidiary axis. This is a BF3. So this is a 1C2. Look at here. Both the fluorine can change their position. Similar way, say other two C2 are there. So these are the 3C2 and 1C3, which is passing through boron. So C3 and 3C2 are present, and C3 is a principal axis. When the molecule having more than one rotation axis of different order, then the highest pole axis passing through maximum number of atom is we call principal axis, and it is generally taken on Z-axis. See, this is the ethene molecule. You tell me how many C2 are there? This is the atom number 1. This is atom number 2. Which one is highest pole axis? First, you tell me. If you want atom 1 to 2. कितने एंगल पे रोटेशन देंगे आप?
180.
180. 90 पॉसिबल नहीं है. The reason is why 90 is not possible. Only the reason is if you give a rotation at angle 90 on axis which is perpendicular to plane which is on your side. Suppose if you trying to give rotation about this C4, then definitely H1 and H4 can change their position, but you are getting a structure like this way. Double bond is comes vertically. In original structure, it is horizontally, but now it is comes vertically. So you are not getting C equivalent position. Look at here. So both are different structure. This is a different geometry. And therefore, you cannot have a rotation at 90 degree. This axis is not there. So only the option is you can have a C rotation about it. You can say 180. This is C2 axis. Atom 1 goes to which position? If you rotate about this axis. Which two atom can change their position?
1 and 4.
Yes, good. 1 and 4 and 2 and
2 and 3.
yes, very good. What's about this C2 axis? These two are in the plane of mobile.
1 and 2 and 3 and 4.
Yes, and of course, carbon also can change their position. Carbon number, okay, 1 and 2 can change their position. And see, these two are in the plane of mobile. Now we can imagine the axis which is perpendicular to plane of mobile. That is here, it's a C2. Now if you take this axis, then you tell me which two atoms can change their position.
2 and 4 and 1 and 3.
Yes, good. 2 and 4 and 1 and 3 and also both the carbon. They can change their position. So see, all these three C2 are different. And highest pole axis is a C2, nothing else. Okay, it's a C2. Out of this three, you tell me which one is a principal axis.
C2 and C4 के axis है ना वो axis.
या 1 and 4 जो पोजीशन चेंज होती है वो C2, ये जो मैक्सिमम एटम में से पास होगी दिस C2. See, axis which is passing through maximum number of atom, that is we call highest pole axis. एक्सिस ज्यादा है तो उस केस में मैक्सिमम एटम में से जो पास होगी वो है प्रिंसिपल एक्सिस. This is a principal axis. Okay, this axis is called principal axis, and remaining axis is called subsidiary axis. So this C2 is, you can say, principal axis passing through maximum number of atoms. These are the other two C2. So this is your principal axis. Okay. So see, in the ammonia, just recognize the axis. What happens in the ammonia?
C3 axis.
C3 axis is passing through which atom?
H1.
Because it's a C pyramidal shape. H1 में से C3 पास होगी.
नहीं C पास हो गई.
C2.
हाँ C3 नाइट्रोजन से पास हो गई. Perpendicular.
C3 is passing through nitrogen atom. Okay, good. So one C3 is there. How many C2 are there?
C2.
फर्स्ट वन बताओ.
फर्स्ट वन H1 से पास होगा.
H1 में से आप पास करोगे तो दोनों हाइड्रोजन कहाँ पे है? वो डार्क लाइन बताई मैंने, वेज डैश प्रोजेक्शन बताया, तो दोनों हाइड्रोजन कहाँ पे है वेज प्रोजेक्शन में? आपकी साइड है या पीछे की साइड? It's a pyramidal geometry. Above the nitrogen, it's a lone pair, and below it, 3 hydrogen are there. Now you tell me, if you take a C2 axis passing through hydrogen and rotate the molecule at 180, then is it you are getting equivalent structure?
No.
No, because both the hydrogen are below the plane, they are goes to above the plane. So C2 axis is absent, so only this molecule have a which axis?
C3.
C3, good. What happens if you give rotation at 120?
H3 to H2 and H2 to H1.
Yes. Second time, and if you give third time rotation, then you are getting similar structure. And therefore C3 raised to 3 is called E, and C3 is your principal axis. What happens in platinum Cl4? Which one is principal axis?
C4.
C4. What happens if you give second time rotation?
C2 to C1.
And third time?
C3 to 2.
If you want to direct this third structure from first one, is it possible in any way, either rotation or in any direction? वन है ना, उनको 4 की जगह चाहिए आपको, और 4 is come to 3 and 3 is comes to position of 2 in original structure. Direct possible है?
Yes, sir, 90 degree clockwise.
Yes, not it is clockwise. Yes, of course it is clockwise, but what we call this axis? Plus or minus?
Yes, plus. The
नहीं,
minus.
yes, minus हो गया.
Minus means clock.
Yes, minus means clockwise. So C4 raised to 3 times rotation आपने दिया है. So C4 raised to 3 is similar to, it is equal to, यहाँ पे 1 time दिया है rotation and यहाँ पे 2 time. See here it's a, you know, here it is 1 time and here it is 2 time. So C4 raised to 3 is equal to C4 raised to minus 1. Good. That is clockwise rotation. And of course C4 raised to 4 is equal to E, but if you want to directly this structure, then you can go for C4 raised to minus 1. What happens if you apply this C2?
C4 to C1 and C3 to C2.
Yes. What's about this one?
C2 and C1 and C3 to C4.
1 and 2 and
2.
3 and 4. Yes. What's about this one?
C4 into C2.
Yes. And in this case?
C3 to C1.
This is 1 C2 C. Rotation is given at angle 180. Second C2. Remaining 2 C2 are in between the bond. Where is your principal axis in this case?
C3.
C
3.
3 or 5? This is cyclopentane. 360 circle is divided into how many parts? Circle is divided into 5 parts. So this axis is, you can say, C5. If you give rotation about this axis, then what is position of 1?
4. 1 to 4.
1 कहाँ पे आएगा?
4 पे आएगा.
2, and 2 is coming to
3.
3. Yes, good. In this way, see, this is 1 time rotation. What happens if you give second time rotation?
2 to 4.
Yes. Then third time. Fourth time. And if you give rotation fifth time, then you are getting original structure. See, 1 time, 2 time, 3 time, 4th, 5th. So you are getting original structure. How many C2 are there in this case?
Three C2.
Where is first one?
First one has a 4 to middle
4
and middle.
yes, middle bone. Second,
3 to 1 and 5 middle.
so how many such C2?
3 C2.
Just look at molecule again and tell me proper. 3, it is not 3, it has more than 3 C2.
5 C2.
Yes, where is first one?
Sir, one passing through 1, second passing through 2, 3.
So passing through every atom, okay? So first one is passing
sir.
through 1 and between 3 and 4. Second is passing through 2 and between 4 and 5. Third one is passing through 3 between 1 and 5. Fourth one is passing through atom number 4 and between, you can say 2 and 1. And fifth, atom number 5th and between 2 and 3. So these are the C5C2. This is 1 C2. This is 1 C2. Second one is passing through atom number 2, you can say this one. This is, you can have a third C2. And 4 C2. In this way, see, there are Y C2 is there. Okay, so these are the 5 C2. What's about in benzene? Where is principal axis?
C4. C6. C6.
C6, yes. Passing through center.
Yes, sir.
This is C6, is principal axis. How many times if you give rotation, then you are getting original structure?
6 times.
6 times, yes. How many C2 are there?
6 C2.
Yes, 6 C2. First one is passing through atom number 2, 1 and 6. Then 2 and 5. So these are, this is 6 C2. Now in this molecule, you tell me the highest pole axis.
C2.
C2 is there, which is passing through carbon, yes. Other than C2, is there any axis?
Yes, sir. OCO.
C?
OCO. बॉन्ड है ना
वहां उसमें से पास होगी, गुड. उसका नेम क्या होगा?
प्रिंसिपल एक्सिस.
प्रिंसिपल, बट वो जो है वो उनका C2 C3 कौन सी होगी? उनका नेम तो कुछ होगा ना?
Yes, sir.
Just a minute.
C2 axis.
Sir, there can be so many lines passing within the atoms of oxygen and carbon.
what is the minimum angle of rotation which will give you identical structures. So that is very, very important. And that's why you can go for, see, this axis passing through oxygen, sulfur, sorry, oxygen, carbon, and
Oxygen.
another oxygen. Good. So you just think about minimum angle of rotation. What is it? कितने मिनिमम एंगल पे आप रोटेशन देंगे तो आपको इक्विवेलेंट स्ट्रक्चर मिलेगा, दैट इज मोर इम्पोर्टेंट.
180.
180 तो है ही, उसके लिए तो इट्स अ बिग एंगल. हाईएस्ट फोल्ड एक्सिस के लिए एंगल जो है वो मिनिमम होना चाहिए. Look at here, see, this is the axis. This is the
36.
axis. See, suppose I give rotation at 180, of course all these three atoms can rotate at a time. So structure तो equivalent ही रहेगा, तीनों एक ही लाइन में रहेगा, because it's linear shape. It's a linear. I will give you rotation at 90, again same, तीनों साथ में ही रोटेट हो गए. आप 1 डिग्री पे रोटेशन देंगे तो भी तीनों साथ में ही रोटेशन तो करेगा ना.
Yes, sir.
तो एंगल जो है वो मिनिमम ही रहेगा, दैट इज 1. जितना भी आप कम करोगे उतना. तो एक्सिस को नेम देंगे C360. 80 180 पे है तो C2 है, 90 पे है तो C4 है. इससे भी कम एंगल हो सकता है, 1 से भी कम वैल्यू. यस, 0.1 एंगल पे रोटेशन देंगे तो भी सेम स्ट्रक्चर रहेगा. 0.01, 0.00000001, 0.1000 times 01, 0.1 crore times 01. Okay, what should be the minimum value of angle? Angle close to
0.
0. Yes, angle close to 0. If it is tends to 0, then see, angle and fold are inversely proportional. If this is tends to 0, then n tends to,
Infinity.
yes, n tends to infinite. And therefore this axis is called C infinite. This is your principal axis. Of course, you can have a C number, n number of C2, infinite number of C2 here. Okay, you can take a number of C2 at a time. You just rotate at 180, then oxygen goes to position of oxygen because it is linear shape. But here, principal axis is C infinite and remaining other axis are C2 is there. So look at here, see, this is your principal axis. Okay, so this is about axis of rotation. We have just completed proper rotation axis. It is still required to understand improper, that is called alternate axis. So that we take later on. After understanding plane of symmetry, then we go for improper rotation axis. So this is the proper rotation axis that is we have completed. Now plane of symmetry, there are 3 types of plane. How many types of plane? In the plane of symmetry, we are having, see, there are 3 types of plane.
Sigma B, sigma D, and sigma H.
Yes. First one is, you can say, sigma H, that is called horizontal plane. What is definition of horizontal plane? So plane which is perpendicular to principal axis. Principal axis तो आपको पता है, that is called highest pole axis, passing through maximum number of atom. So plane which is perpendicular to principal axis is called sigma H. And vertical plane, that is called plane which is parallel, or you can say passing through principal axis. And third one,
Lies means axis lies.
yes, plane that is called bisect plane. This is diagonal plane. This plane is generally bisect two C2 axis. Bisect, sorry, C2 axis and principal axis at 90 degree. Bisect C2 axis and principal axis at right angle. Or it is just a vertical plane. It is vertical plane. If molecule having more than two vertical plane or more than one type of vertical plane, then the plane which is passing through minimum number of atom, it is called diagonal plane. But it is a vertical plane passing through minimum number of atom. So this is, we call, see, it is nothing but it's a principal diagonal plane. So there are three types of the plane which is perpendicular to principal axis, plane which is parallel to principal axis, and plane which bisect angle form between principal axis and C2 axis. Or you can say, if molecule having more than one vertical plane, then plane which is passing through minimum number of atom, so that is we called diagonal plane. So if the molecule is divided by plane, so same atoms are found on both the half. Whatever object or whatever things are there on right side, same things are observed on the other side, that is on left hand side. Then and then we can take this that one as a plane. So you are getting, see, reflecting mirror image on both the side. So that is we call molecule having plane of symmetry. It's an imaginary plane in a molecule that divide two equal parts of atoms, or you can say two parts related with each other. So that is we call plane of symmetry. Is there in this molecule there is a plane? Can we divide this molecule into two equal parts by cutting it?
Yes, sir.
Yes. From where?
Middle, sir. Middle. See the
Yes, it is from the middle part. You can have a mirror image. See, look at here. You can put here plane. Okay, is it okay? So
yes.
right side is a mirror image of left side. You just cut it. You are getting C two equal part. So therefore, this is the plane of symmetry. Here, see, it's a plane of symmetry. Molecule is divided into two equal parts. Our body is a bilateral symmetrical. From middle, we can imagine the plane. This pencil also has a number of planes in each corner parts. You are having plane. So simply the plane are of three types: sigma h, sigma v, and sigma d. So here, see, sigma h means plane which is perpendicular to principal axis. Now look at here, see, this is a BF3 molecule. Now in the BF3 molecule, where is principal axis?
Middle, sir.
This is in plane of mobile or perpendicular to mobile, whatever structure is given. I am asking about this structure. In this structure, it is in
Perpendicular.
the perpendicular. It is not perpendicular. ये तो आपके मोबाइल के प्लेन में ही है C3.
Yes, sir. Some more things.
This is more on C, and this atom is on back side. This is on back side and this is front side. But आप ऐसे suppose molecule draw करोगे यहाँ पे, ये if you take these three atoms in the plane of mobile, or you can say in the plane of laptop, then see, this is now C3 axis is on your side. Now C3 axis which is perpendicular to you. Okay, but here it is in the plane. So see, our definition is plane which is perpendicular to principal axis. So here principal axis is there, C3. So perpendicular plane is this one passing through all this boron. Yellow color plane, see. Okay, all the atoms are found in the plane, so you are not getting mirror image. You are only getting mirror image of those atoms which are either on right side or on left side, or it may be on above or below the plane. But those atoms are there in the plane, they will never give you mirror image. So see, this is your sigma h. What's about in this molecule? See, this is sigma h. Sigma h is your plane of your mobile, because principal axis is perpendicular to plane of mobile, and therefore this is your sigma h. So this plane is, you can say it's a sigma h. Vertical plane is nothing but plane which is passing through principal axis, or you can say parallel to principal axis. So sigma h is always 1 in number, it is not more than 1. If sigma h is present and sigma v is also present in the molecule, then number of sigma h is only 1. And if both the plane are present, then number of sigma v is equal to number of principal number of C2 axis. अगर दोनों प्रेजेंट है मॉलिक्यूल में सिग्मा एच एंड सिग्मा वी, तो जितनी आपकी C2 एक्सिस होगी उतना सिग्मा वी होगा. But sigma h is always 1 in number. So this is C2 axis. Can we take here sigma h? Yes or no? This is C2 axis, which is in the plane of mobile. So can we take plane which is perpendicular to C2 axis in this way? Is it possible?
No, sir.
No, because if you are applying this plane, then what happens? You are getting non-equivalent structure. Okay. So this is you cannot take. So now you tell me, in the water molecule, is there any sigma V? Sigma V means plane which is passing through principal axis, that is the C2 axis,
Yes,
or
sir.
you can say plane which is parallel to C2 axis. Is there any sigma V?
Yes.
Yes. Where is it? कहाँ पे आएगा?
Okay, बराबर.
This is one which bisect the molecule. So you are getting, see, mirror image. H1 is reflected as H2 और H2 is reflected as H1. तो एक तो ये है, दूसरा है
नहीं है.
सी वन इज बाइसेक्ट प्लेन दिस वन. दूसरा सी ये तीनों एटम एक ही लाइन में है. 1 2 and oxygen, hydrogen and oxygen. See, this is a bent structure, V structure. If you just visualize V, so all these are in a same plane and they are in the plane of your mobile. सब एक ही प्लेन में है, मोबाइल के प्लेन में. तो आप ऐसे प्लेन नहीं ले सकते
Yes,
which
sir.
cover all these three atom.
H2O and H2 हाइड्रोजन ऑक्सीजन हाइड्रोजन के प्लेन के बराबर काटेगा.
क्या?
हाइड्रोजन ऑक्सीजन हाइड्रोजन प्लेन है ना, उस प्लेन से जाएगा.
नहीं, आप ऑक्सीजन और दोनों हाइड्रोजन को कवर करेगा ऐसा प्लेन नहीं ले सकते.
सर वो प्लेन तो बोल रहा हूँ, तीनों एक ही एटम.
एक क्लोन पे यहाँ ऑक्सीजन पे फ्रंट साइड होगी, दूसरी बैक साइड होगी, तो मिरर इमेज मिल जाएगी आपको. ओके. एटम जो प्लेन में आएगा उनका रिफ्लेक्शन नहीं मिलेगा, वो एज इट इज रहेगा. सपोज आप ये प्लेन सिग्मा वी जो है सेकंड लिखा है मैंने, वो अप्लाई करोगे तो रिजल्ट क्या मिलेगा आपको? सेम रिजल्ट मिलेगा, क्योंकि ये प्लेन में सारे एटम्स है वो इन द प्लेन है. जो एटम्स इन द प्लेन हो गए वो अपनी पोजीशन चेंज नहीं करेंगे. सो यू आर गेटिंग सेम रिजल्ट. सो व्हाट यू कैन डू हियर, यू आर गेटिंग सेम रिजल्ट. H1 अपनी जगह रहेगा, H2 अपनी जगह रहेगा. दोनों लोन पेयर है ना, वो अपनी पोजीशन चेंज कर देंगे ऐसे. जो आपके पास दो लोन पेयर है, सो दे कैन चेंज देयर पोजीशन. जो रेड कलर वाली है वो अबव द प्लेन चली जाएगी, ब्लू कलर वाली है वो बिलो द प्लेन ऐसे. So only lone pair can change their position. Rest of the things remains as it is. Okay. So these are the C2 sigma V, and if you apply this sigma V1, Then what happens?
Identical.
Yes, यहाँ H1 आ जाएगा, यहाँ H2. It's a reflection plane. Okay, H1 and H2 can change their position. H1 जो plane की right side है वो left side चला जाएगा, left side है वो right side. So H1 and H2 can change their position. This is one sigma V. One and two can change their position. Yes, I see. Okay. One and two can change their position. Yes, I see. 2 and 3 can change their position in BF3. So this is called sigma V. And this is the second sigma V, which is passing through all the atoms. That is plane of your mobile. This is second sigma V. See, positive part is there, that is front side part, which is comes to back side. So plus sign change to minus. See. But atoms remains as it is. One remains at position of 1, 2 remains at position of 2. So atoms cannot change their position, just sign of rotation. That is lone pair, or those things which are in the front side are reflected on back side. So see, these are the two sigma V in a water molecule. Tell me in BF3, where is, see BF3 is a planar. So where is sigma H? Principal axis is on your side. This example we have already taken. C3 is a principal axis which is on your side. So where is sigma H? कहाँ पे आएगा?
P and 1 plane. B boron F1.
Yeah, yes, that is plane of your mobile. Okay, which because principal axis is perpendicular to plane of mobile. So this is your sigma H. Good. This is and sigma V. See, this is sigma V. What happens? If you take this sigma V, then F2 and F3 can change their position. If you take this sigma V, then F1 and F3 can change their position. And if you take this sigma V, then F1 and F2 can change their position. And that's why I have told that if molecule having sigma H and sigma V, then the number of sigma V is similar to number of C2 axis. इसमें 3 C2 axis है तो 3 sigma V आएगा. This is 1, 2 and 3. Is it okay?
Sir.
And this is a sigma H, that is passing through all these three fluorine as well as boron atom. This sigma H is perpendicular to principal axis. But in ammonia, if you compare it with ammonia, so ammonia does not have a sigma H. Principal axis is there, which is on your side. So of course, passing through principal axis, there are 3 sigma V. This is 1 sigma V, this is 2, and this is 3. But you cannot take a sigma H. Otherwise, lone pair is on your side, which is reflected on back side. So that is not a similar structure. So this molecule having only 3 sigma V. Here 3 sigma V is there and 1 sigma H is also there. Another difference between this molecule is BF3 has 3 C2 axis, but NH3 does not have any C2 axis. There is no any C2.
Because of lone pair.
Yeah, and similarity is both having principal axis in C3, but here there is no C2, but here there are 3 C2. Of course, 3 sigma V is there in BF3, but in NH3 there is no such 3 sigma V. This is the molecule. Look at here. This is a C3 axis. You cannot take sigma H here in this way. You cannot take this plane. Otherwise, both three hydrogens are there which are below the plane. That 3 hydrogen are reflected above the plane. So this is not equivalent structure. Now see, sigma D is nothing but sigma D is one kind of sigma V. If there are more than one type of sigma V which are present in molecule, more than one type, then plane which is passing through minimum number of atom and divide the two C2 axis at right angle, or you can say C2 axis and principal axis at right angle. So that is called sigma D. Plane passing through maximum number of atoms, and that is we give the name sigma V. But plane which is passing through minimum number of atoms, so that is we called sigma D. See, in platinum Cl4, this is a very good example. Platinum Cl4. See, this is a 1, this is C4 axis, which is on your side. So this is 1 sigma V, second sigma V, third sigma V, and 4 sigma V. Out of this 4 sigma V, you tell me the sigma D. Which are 2 sigma D and which are 2 sigma V?
So the plane passing through 1 and 3 and 2 and 4.
1 and 3 and 2 and 4 are called sigma D or sigma V?
D. D and
D.
V also.
Now coming back to the definition of sigma D plane. Second point. If molecule having more than one type of sigma V, then plane which is passing through minimum number of atom. That is called sigma D. Okay? You see your answer. What we call plane which is passing through 1 platinum and 3. इस प्लेन को क्या बोलेंगे? ये सिग्मा डी कंसीडर कर पाएगा इसको? Can we consider it as sigma D or not?
Sigma H.
एच तो है ही नहीं. एच तो है ये पूरा प्लेन है जो स्क्वायर वाला बोर्ड पेपर का प्लेन. इसकी बात मैं नहीं कर रहा हूँ. प्रिंसिपल एक्सिस आपकी साइड है. मोबाइल के प्लेन को आप ऐसे परपेंडिकुलर रखो तो उसमें से आप प्लेन ड्रॉ कर पाओगे. ये प्लेन है ना, ऐसे आपका फुल स्केप या नोटबुक उस पे डालोगे ये 1 and 3 एटम पे, तो वो ऑटोमेटिकली प्रिंसिपल एक्सिस को कवर करेगी. ये सारे प्लेन है वो प्रिंसिपल एक्सिस को कवर करेगा, इसलिए सारे प्लेन सिग्मा वी है. बट सिग्मा डी किसे बोलते हैं? इसकी डेफिनेशन क्या है? सिग्मा वी तो है ही सब, ये भी सिग्मा वी, ये भी सिग्मा वी. बट ये जो प्लेन है, दोनों प्लेन ये मिनिमम एटम में से सिर्फ पास होता है, इसलिए इनको सिग्मा डी बोलेंगे. इससे पहले तो इसमें ये चेक करो, इसमें 2 टाइप के सिग्मा वी है. 2 टाइप इसलिए है, 1 सिग्मा वी विच इज पासिंग थ्रू 3 एटम्स. एक ऐसा सिग्मा वी है जो 3 एटम में से पास होगा. एंड अदर टाइप ऑफ सिग्मा वी विच इज पासिंग थ्रू ओनली 1 एटम. तो ये दोनों में से 2 तरह के सिग्मा वी है. तो उस टाइम हम जो मिनिमम एटम में से पास होगा उस सिग्मा प्लेन को, उस सिग्मा वी प्लेन को नेम देंगे सिग्मा डी, दैट इज कॉल्ड डायगोनल. नाउ इज इट क्लियर? So out of 4 sigma V, you can have a 2 sigma D and 2 sigma V. So this is called diagonal plane. These 2 are sigma D and these 2 are sigma V plane. And this is what we call this green color plane. What we call this green color plane?
Sigma H.
Yes, it's a sigma H. That is perpendicular to principal axis. See, principal axis is on your side, so plane of your mobile, this is a square planar geometry. So this plane is perpendicular to principal axis, so this is called sigma h. Good. So it's a sigma h. In this way, there are three different types of planes are there. See, this is a sigma v. Principal axis is C4. This is staggered geometry. This three red color is on overside. See, this is C3 principal axis. What do we call this plane? Of course, mirror sigma h ले सकते हैं इसको परपेंडिकुलर है, बट यहाँ स्टेगर्ड में मिरर इमेज नहीं है। सी आप ऐसे मिरर इमेज नहीं ले सकते, but sigma d is there. See, this is sigma d, plane which bisect this cross plane. Plane which bisect angle formed between C2 axis and C3 axis at 90 degree. This is your sigma d. This is second and this is third sigma d. इसी तरह आप क्रॉस 3 sigma d ले सकते हो. See, these are the sigma d plane which are there in staggered conformation. Sigma d is present in staggered geometry. But what happens in eclipse structure? What we call this plane? This is your principal axis C3. H1, H2 and H3, H4, H5 and H6. This is eclipse structure. So this is C3 axis. So this plane is called
sigma h.
Sigma h, yes. But in the case of staggered geometry, such sigma h is absent. Look at here. You cannot take sigma h. But this is C3 axis and this is C2 axis. So plane which bisect these two axes at 90 degree. This is called sigma. Cross plane is called sigma d. This is in a staggered, there are sigma d. This is eclipse where sigma h is there. These three are sigma d and these three are sigma h. This is sigma, sorry, these are the sigma v. 3 sigma v is there and sigma h is between carbon-carbon bond, whatever we have written. See, this plane is between carbon-carbon bond. Pink color, purple color हाइड्रोजन वाला जो कार्बन है, ब्लू कार्बन वाला, पर्पल कलर हाइड्रोजन वाला वो पीछे आएगा, ग्रीन कार्बन है वो फ्रंट साइड आएगा. तो ये दोनों के बीच वाला प्लेन है ये, दैट इज कॉल्ड सिग्मा एच. सिग्मा एच, this is sigma h. See, this is, you can say, plane of symmetry. Up to here, is it clear?
Yes.
Yes. So thank you very much. Now up to here, see, we have just covered three types of plane and principal axis. Yes.
सिग्मा एच एंड सिग्मा डी में थोड़ा और डिफरेंस बता दीजिए.
सिग्मा एच एंड सिग्मा डी में सी, सिग्मा एच जो है वो आपकी प्रिंसिपल एक्सिस है, जो भी प्रिंसिपल एक्सिस, उसको एग्जैक्टली आपको परपेंडिकुलर लेना है और वो एक ही प्लेन आएगा, वो एक से ज्यादा नहीं आएगा. आपके प्रिंसिपल एक्सिस इन दी प्लेन है तो आपका सिग्मा एच जो है वो आउट ऑफ प्लेन आएगा, और आपके प्रिंसिपल एक्सिस है वो आउट ऑफ प्लेन है तो जो सिग्मा एच है वो इन दी प्लेन आएगा. सी, लुक एट हियर, दिस इज योर प्रिंसिपल एक्सिस. ओके, ब्लू कलर में से पास होती है तो उसको परपेंडिकुलर ये पूरा येलो वाला, इसको सिग्मा एच बोलेंगे. और सिग्मा डी है ना वो वर्टिकल प्लेन ही है, और वर्टिकल प्लेन की डेफिनेशन क्या है? पासिंग थ्रू प्रिंसिपल एक्सिस. पैरेलल होगा. तो उसमें से जब मॉलिक्यूल में एक से ज्यादा सिग्मा वी है, मॉलिक्यूल में सपोज एक से ज्यादा सिग्मा वी, दो तरह के सिग्मा वी है, तो मिनिमम एटम वाला आप चूज कर लो, उसको सिग्मा वी भी बोल सकते हो, और इट इज कॉल्ड सिग्मा डी. और दूसरी डेफिनेशन जो अभी स्टेगर्ड स्ट्रक्चर में लिया, दैट इज आपकी प्रिंसिपल एक्सिस है और C2 है, उनको बाइसेक्ट करेगा, या तो दो C2 एक्सिस को बाइसेक्ट करेगा ऐसे. ऐसी तरह just look at here, ये जो H1 है यहाँ पे, AH2 और AH3 है, AH यहाँ पे सॉरी H4 यहाँ नहीं आएगा. It's just a clear cut difference between these two. Look at here. This is a eclipse. We want a stagger structure, and that's why we write down here H4, H5 and H6. ये एक्सिस जो है ना वो C3 है, तो इसको परपेंडिकुलर यहाँ ऐसे हम प्लेन नहीं ले सकते. ले सकते हैं ऐसे? लेफ्ट साइड वाला पार्ट राइट साइड
No,
दिखाई
sir.
नहीं देता, तो ये सिग्मा एच एब्सेंट है. चलो ये तो समझ में आ गया.
Yes,
अभी
sir.
सिग्मा डी की बात करते हैं, तो यहाँ से ऐसे आप C2 एक्सिस ले सकते हो. 180 पे आप आपकी साइड लेके रोटेट देंगे, ये 6 1 की जगह जाएगा, 6 यहाँ आ जाएगा, दोनों आपस में पोजीशन चेंज करेंगे. एसीसी यहाँ पे 3 C2 है, ये सब समझ लो. C2 आपकी साइड है 90 डिग्री पे, ये C3 यहाँ बोर्ड के प्लेन में है, या तो प्लेन ऑफ लैपटॉप. तो ये वाला जो यहाँ है ना, ये प्लेन
सर स्टैगर्ड में कैसे हो रहा है? ये इक्लिप्स्ड में होगा ना सर?
स्टैगर्ड में आएगा. सी ये जो प्लेन है ना, ये जो क्रॉस प्लेन, ये दोनों की मिरर इमेज यहाँ मिलेगी.
यस सर. ओके सर. यस
तो
सर.
ये क्रॉस वाला प्लेन है, इसको क्या बोलेंगे? सिग्मा डी. और
Yes,
ये
sir.
देखो, ये C3 में से भी पास नहीं होता है, C2 में से भी नहीं, बट वो दोनों के बीच में से
ओके सर.
इनको बाइसेक्ट करेगा. ऐसे 3 सिग्मा डी आएगा. इक्लिप्स में ये पॉसिबल नहीं है.
ओके सर.
इक्लिप्स में तो सिग्मा एच है ना, ऐसे देखो, ये सिग्मा एच है. ओके, तो इसमें पॉसिबल नहीं है, इसमें आप ऐसे नहीं ले सकते प्लेन. So this is the case with stagger structure. We will make more practice so you can understand it well.
ओके
Tomorrow,
सर.
tomorrow we will also take an example of alien molecule. So alien molecule is very easy to understand, sigma D plane. Thank you very much.